Don't talk of linear momentum. Is a momentum in a straight line. When you say momentum, momentum means movement. Momentum means what? Momentum means movement. Momentum means what? Movement. Momentum means motion. So we do motion on a straight line. Now, everybody, class read. The momentum of the body is product of its mass and its velocity. Product means multiplication. Multiply the mass of the body. If your mass is 5 grams or 5 kilograms. If your mass is 5 kilograms and the velocity at which you are using to run, they will get your momentum. The mass of the body and the velocity in which the body is using to run will give us what? Momentum. So what's momentum, class? Is the product of mass and the velocity. Is the product of mass and the velocity. Now, given that what? Read. We normally use P to represent momentum. Mass is what? And velocity is what? V. Now, momentum equals what? Mass and velocity, mv. So the unit of momentum is what? Why they say kilogram per second? Because unit of mass is kilogram. Velocity is meter per seconds. So unit of momentum is kilogram meter per seconds. Now, and momentum is a what? Vector quantity. I just need to know about momentum. Momentum is a vector quantity. Now, that is, it has what, both what? A straight line. Now, the momentum is represented by what? P equals what? Sometimes called so distinct from what? Angular momentum is found in a circular motion. Now let's go on now. Impulse now. If you hit your hand on a plank, the time in which you use to hit your hand, that time and the force that you applied, when you multiply them together, you have got the impulse. You have got what? Impulse is the product of what? Average force and what? Time during which the force is applied to the body. Oh yeah, read the impulse again. Is the what? Product of what? Average force acting on the body of all particles and the time during which it acts. I can't hear you. The impulse is the product of the average force acting on the body of all particles and the time during which it acts. So we have no definition of momentum. Momentum is mv, product of mass and the velocity. Impulse is the product of average force acting on the body and the time during which it acts. Now, given that what? Then impulse equals what? I equals to Ft. Impulse equals what? Ft. So you have known two formula now. Momentum formula is mv. Impulse formula is what? Ft. Okay. Now, Newton's law of motion. Oh yeah, read. Newton was the first to now we have the law of motion and the first Newton's first law of motion now states that uniform motion in a straight line unless it is acted upon by an external force. Every object will continue in a state of rest. You will continue resting unless somebody push you, and you continue moving like this unless your direction can change if somebody was push you. So if the external force is the push from somebody or from something. So now every object say that every object continue in a state of rest or uniform motion in a straight line unless what? It is acted upon by an external what? Force. That's first law of what? Motion. That's Newton's first law of motion. And yeah, that's what Newton's what? First law of motion. What of Newton's second law of motion? Now yeah, look at it. See with one.
continue to remain at rest unless a force acts on it.
Now I've mentioned here.
Meaning your death will remain in its position until you are not sure. On the other hand, it continually continue to move in the same direction unless a force acts on it.
Unless you can change that unless a force act on it. However,
you will observe that the action of grace giving a push and then release slides on the ground and stop on the floor. Also, when you turn on the engine of a car, it moves for some time and comes to rest on the floor. Which force is bringing this body to rest? It should be under friction of gravity or other external forces which are not noticeable are responsible for slowing this object and bringing them to rest.
now when they push something from the top of it, it's gravity that will make it to come to rest. Because when you jump also, gravity will make it to what? Come to rest. That's gravitational force. Friction in a car will also make the car to come to rest. Now, that's Newton's first law of motion. We also have Newton's second law of motion. I would like you to pen some things down. Now, I believe you cannot define momentum now. What is the definition of momentum? Write momentum. Write the definition yourself. It's the product of mass and velocity. Product of mass and its velocity. Write the definition yourself. Momentum is the product of mass and its velocity. Write it yourself. Where is your pen? Class, what's inertia? God, they have a greater what? Now look up. Let's read that inertia again. Is the what? Tendency to remain in state of rest or uniform motion in a straight line. So a truck has a greater inertia. That's why it implies to just remain in uniform motion when you apply brake. So a fat person, you can't compare a fat person and a tiny person. If a fat person will stand up, the person will say, but tiny person will just stand up. Because of the inertia is different. So is the tendency of a body to remain in a state of rest or uniform motion in a straight line. Now read class. Yes. Reluctant to stop. That's inertia of what? Motion. Inertia at rest, that's the reluctant of body to move. Inertia of motion is the reluctant of body to what? Stop. Am I communicating now? That's inertia. So you can also say it's the reluctance of body to remain in their state of rest. It is the reluctance of body to remain in the state of rest or uniform motion in a straight line. Or no, is the reluctance of a body to change its state of rest. I get it now. Is the reluctance of a body to change what? The state of rest or uniform what? Motion in a straight line. Is the reluctance of a body to change the state of rest. The body wants to remain at rest. Or can also say the tendency of a body to remain in a state of rest or uniform motion in a straight line. Right definition of inertia. I think I told you a fat woman and a tiny girl, a truck and a car. I gave you an example. The more the mass, the more the inertia. Okay, Mass. Look at this boy now. You can see he's moving, right? Is he moving back or moving my direction? Now, because I applied the force, right? Now, when you get momentum, when the ball is at rest, what is his velocity? His velocity is zero, right? But when I apply force, his velocity change, right? Let's say he's moving with 1 meter per second. And there's a time applied to the movement also, right? Now, and that time is the rate. Let's say it moves in 5 seconds. Now say the resultant force is the force that causes the body to move. Oh, resultant force is the force that causes the body to what? I apply the force to it. That force one might be dragging. This girl might be dragging him, and I'll be dragging him. But if my force is greater than her force, I will drag this boy forward. That the force for me to drag him forward, my force greater than his force. That force that makes him move is what? Resultant what? Resultant force. Now, the resultant force is the force I applied. Now, resultant force. Let's say I applied 10 Newton. Now say that the second of motor state that the resultant force caused me a change of momentum, change of movement. It was at rest before. Change of movement of the body. Is what? Directly proportional. This is symbol to the time rate of change of momentum. Change of momentum. What momentum? Momentum is mass times what? Velocity, right? Time rate of change of momentum. Now, the velocity is two types. When it is at rest and when it's moving. So now m over v minus u over t, right? F m u is what? U is initial velocity 0, v minus 0 over t. My v is what? 1. Now this is what they call change in momentum. How? This thing can be mv minus mu. When they say change of something, that's final minus initial. Final velocity. Now, is the laptop ready now? Now, final momentum minus initial momentum. Momentum is mv, right? mu is also momentum. Momentum is also velocity. This is u is also velocity. I mean initial velocity. mv minus mu. Change the momentum. If they ask you now that how old were you when you are in year 2017, how old were you? Let's say you were 10 years. Now he is year 2025. Now you are now 18 years. Now what will change in your age? Your final age in year 2025 minus initial age, that is now what? 8 years. It was not recorded before. It was not recorded before. Now we start from this one, right? Or the inertial. Now your final minus initial is what? 8, right? That's your change in what? We use triangle A, change in H, change in A. Am I completing now? So change in momentum is what? mv minus what? mu. mv minus what? mu. So now therefore I'll say my final velocity 1 minus 0. 1 minus 0 is what? 1, right? That's now what? F equals what? M. I will change this one to equals to K as variation in mathematics. Now M over bracket 1. Let me see right V minus U over T. And our K is equals to 1. Our K is equals to what? 1. So F equals what? M over bracket V minus U over T. This is the formula relating to this second law of motion derived by Newton. Now let's read it again. This second law of motion says that what? The more I apply force to to drag this ball, the faster his velocity, the faster he moves. Now what's the of that? The higher the force, is direct proportional. This means direct relationship. The higher the force I applied, the faster the ball moves. The higher the force I applied, the faster the ball was, the faster the rate of change of momentum of the ball. Don't write when I'm talking, listen. The higher the force I applied, the faster the ball moves. So if I apply greater force to move, it's going to move with a greater momentum. Am I communicating now? Write Newton's second law of motion. Write in the second law of motion. When Newton's second law of motion, that what? Class, you don't need second law of motion. Say that what? It's not the time rate of change of the momentum is directly proportional to the time rate of change of the momentum. That the more you apply force to a body, the faster the body what moves. Now, mathematically, given that what initial momentum mu, final momentum time taking is what c, then change momentum is what mv minus mu. What is it here? M minus mu here. Then where what m is mass of the body, u is what and v is what so therefore they bring out this formula F equals to kma, where k is a constant. I will derive this formula now. What is the formula for velocity, for acceleration? A equals to v minus u over t. Isn't it? That's change of velocity over time, right? Acceleration is the rate of change of velocity. The time rate of change of velocity, time rate of change of velocity. That and change of velocity means what? Final velocity minus what? Initial what? Velocity. That's now A equals what? V minus u over t. Look at that boy there. A equals what? V minus u over t. Now, which that is the time. So wherever I see v minus u over t in my calculation, I can represent with a. That's the meaning of this is equivalent to this. This is equal to this. So wherever I see v minus u over t in my calculation, I can put what? A there. So I can write this as f m times v minus u over t, right? So wherever I see this, I can put what? A. So therefore, I will not say f equals to m a. So F, because this formula comes from what? Newton, Isaac Newton. It comes from what? Isaac Newton. From the Newton's second law of what? Motion. So you can write the derivation. So write the derivation. We are going to be using this formula a lot. F equals to m or bracket v minus u over t. Note this formula. We are going to be using it a lot. 1, 2. We are going to be using it a lot. Write it. Now write this initial momentum equals to mu, final momentum is mv, time taking is t. Look at it now. Look at it. We studied Newton's second law of motion just now, which is resultant force applied to a body is directly proportional to the rate of change, time rate of change of the momentum, right? And royal class, and we derive this formula F equals to m v minus u over t. Then if we multiply now, earlier, that's f t m v minus u, and we divide it plus as what? Product of force is the period of average for action on the body and the time during which it acts, right? Which is impulse formula is what? That's Ft, right? Which means wherever I see Ft in any equation, I can also put impulse there. which means you can also use this formula to calculate impulse. Look up. Wherever is CFT, you can put impulse. What is the symbol? We use I to represent it. I can put I equals what? FT. Or I can say I equals what? M or bracket V minus U. I equals what? M or bracket V minus U. Now, this I did the example. Take the movement of the body from where? 2 kilograms per second to what? This is the change in momentum in what? 0.2 seconds, right? Calculate the magnitude of the impulse. Look up, listen, don't be scared. Impulse is what? Impulse is what? I M bracket V minus U. Impulse can also be what? MV minus MU. And MV is what? Momentum, final momentum. MU is what? Initial momentum. And they give you initial momentum. Change of momentum from 12 kilograms per second, because momentum unit is kilograms per second. The unit of momentum is what? M is what? Kilogram. M is what? V is what? So what unit of momentum? Kilogram meter per hour. Now they give you momentum, initial momentum, and initial momentum is what? MU. They give you final momentum. That's what? 16 MV. And you are looking for what? Impulse, right? Yeah, the time is not useful here. Now, therefore, I cannot say what? Impulse equals what? Final momentum 16 minus what? 12. Impulse is now what? 4. Now you can say meter kilogram per second, or you can say Newton seconds. But if you don't use another formula, you can still use another formula. Abdukudus. That is very powerful. And and the person has effect in this place. Abdul Kudus. If you want to use this formula, you can also use it. Alternatively, you can say impulse equals what? Ft, right? In impulse, you need time and force, right? And they gave you time, 0.2, right? Where is your force? You can use this formula to get your force. That's F equals to mv minus mu over t. Now, you can use this formula to get your force. Mv is what? 16. mu is what? 12. Time is what? 0.2. F, that's 4 over 0.2. 20 Newton. Another way, go and get your force from this because we are doing final momentum and initial momentum. Your force is 20 Newton. You will now come here, put the value of your force here, 20 times your time is what? 0.2. Your time is 0.2. What now this? For any of the two methods, I first get my force. I left him now. So working what? Work is 1. Then I now what? Finish it up here. A ball of mass what? 0.1 kg. Regular mass 0.1 kilogram. Moving with a velocity of what? 20 meters per second. Now let's read the question all through. Moving with a velocity of 20 meters per second, it's by a force which acts on it for 0.02 seconds. This is the velocity of that mass, and this is the velocity of that ball, and this is moving, and it's heated by another force again. Which means the force to change the momentum, right? By a force of what? Which the force acts on it for 0.02 seconds. If the ball moves off in the opposite direction with a velocity of 20 meters per second, calculate the magnitude of the force. The ball is moving with the velocity. Now we have two velocity now. This is the initial velocity and this is the final velocity. This is initial velocity, this is the final velocity. Now the initial velocity initial velocity u is what? 20 meters per second. 20 meters per second. The final velocity is what? We use v to represent it, which is what? 25 meters per second. Initial velocity is what? And the final velocity is what? And the time in which the force act on it is what? 0.2 seconds. So, what I think they gave us again? Nothing. What are we looking for? Force. Calculate the magnitude of force. I'm looking for F. Which formula has all this? F equals to M to bracket V minus U close bracket over T, right? Marvelous. That's the formula you are going to work. Use. Now, that's now what now? F equal to M to bracket V minus U over T. F is what? Is the force, right? M is 0.1. V is what? 25 minus 20. Over time, 0.02. F, this is now what? 0.1 times 5 over 0.02. F 0.5. 0.5 over 0.02. Alright. 25 Newton. F is 25 Newton. So you can solve this yourself. It's just similar to the question we solved now. And the answer is what? C. Now, exercise. Solve one question. Solve this. Solve this. Solve this. Solve this. Solve this. A force acting on a body of mass 10 kg. Change its velocity from 2 meters per second. Calculate the impulse the force delivers to the body. impulse. I also gave you the impulse. It's always written as m v minus u. I gave you this formula m over v my impulse formula. You are not calling it mass velocity, initial and final velocity. Very simple. Right. So Newton seconds, units of impulse. You have solved. Well done. I don't see it in my assignment. You need to get prep 50 for chemistry, physics, biology, and mathematics. Prep what?
So you're beating me just
Prep 50. One is 2,000 naira. It's 2,000 naira. You got it. Good. Now, are you done? What's the answer? Your answer is option what? Answer is option A, 9 Newton seconds. What of this one? What's the answer for this? Solve this. Solve. The more you solve, the better you are. So you can go to that part. There's no time. Are you done? Let me solve this question. Which one? When? Now. Let's start it. Let me start it. Look up. Listen. What are the values they gave you? This and this can work together. Now, u is what? 0. Now, it moves a distance in this time. You can use it to get your final velocity. I get you now? And you are looking for force. Force is what? You can say MA. Am I calculating now? If you want to use this one, you can say force equal to m v minus u over t. So when they gave me this distance and this time, on the horizontal track, which is the direction, you can get a velocity. That is displacement over time. Velocity is distance in a specific direction over time, and the distance is 60 over time 20. Velocity is what? 3 meters per second. That's the final velocity. When a body starts from rest in physics, you have to write u equals to 0. You have to write what? So therefore, that's the initial. There must be final velocity. You can get it from distance over time, which is displacement over time. Distance is a specified direction, and the direction there is the horizontal track. So therefore, which is we have got the final velocity of the body, and the time is what? Time is what? 20 seconds, right? I can use this formula to get my force, because I'm looking for accelerating force, the force that makes the body to move. That's what they call accelerating force. So now F is what? My M is what? Your mass must be in kilogram. V is what? 3 minus U is 0 over what? 20. So therefore, F, that's 800 times 3 over 20. That's now what? 2,400 over 20. That's 120 Newton. 120 Newton. Pause the video. We don't have 120 Newton in the... Listen. We can get velocity writing this. S equals to ut plus half at squared. We have v squared equals to u squared plus 2s. Now listen. When the body start from here, u is 0. My a is unknown. You have your 120 Newton. Let me check. No, it can't be meter per seconds. That's the distance. Diesel. F equals to 240 Newton. Now listen. Is that what? So which is option A? Look up. Listen. How do you now solve yours? As well. It's wrong. Now listen class. Let me explain. Look up. Option A, 240 Newton. Oh yeah, start it. So now look up. When you hear that a body starts from rest, that question will lead you to equation of motion. That question will lead you to what? And what are the four equations of motion you know? V equals to u plus 80. S equals to ut plus half 80 squared. Talk. Now, in an equation of motion, if you are given distance is what? 60 meter. You are given time is 20 seconds. And what are you given again? Nothing. And instead when you start from rest, you are given initial velocity. U equals what? 0. And I'm looking for accelerating force. I can get my accelerating force from this formula. F equals what? Ma. If I know my mass and if I know my acceleration, I will get my accelerating force. Am I calculating now? So look at it now. I can go and get my final velocity. V equals to u plus 80. I can get my final velocity from this formula. S equals to u plus v over 2 times t. I know my distance. I can get my final velocity. I know my time. So now, once I get my final velocity, I can go and put it here and get my acceleration. Am I going to get it now? Now, this is fourth equation of motion. So now, what is my distance? 60. That's 60 equals to what is my initial velocity? Because start from rest, your u will be 0. What is my final velocity? Is unknown. That's what I'm looking for because I need to get acceleration from this formula. Over 2. What is now the time it used to travel this distance? 20. 2 here 1, 2 here 10. I have to do 0 plus v is what? V. 60 equals to v times 10 because this called Lewis multiplication. That is now what? Aliyah. 10v equals to 60. Divide both sides by what? Divide both sides by 10. to what? 6 meters per second. After you have got your V, you can put the value here to get your acceleration. V equals to U plus 80. V is what? 6. U is 0 because starting from left. A is unknown and time is what? 20. That's 6 equals what? 20A. Divided by what? 20. Divided by 20. A equals what? 0.3 meter per second squared. After you have got your acceleration, because we need our acceleration, and all the equation of motion all has final velocity, and you don't even have final velocity. You only have initial velocity, which is 0. You only have initial velocity, which is what? 0. So I need the equation of motion to get my acceleration. Am I calculating now? Musa. So therefore, Musa F equals to MA. I know my acceleration now. 0.3. I know the mass. Your mass was being in kilograms. You are given grams, you convert to kilogram. So now F equals what? M is what? 800. As is 0.3. F is now equals to what? 240 Newton. Offshore A. So the error the other time was that we didn't use the equation of motion. When you have monster formula, go to S. In that question requires formula from equation of motion anywhere. Am I waiting now? We are busy. Now, write the solution. So the solution starts from here. Another way of solving it is not using two formula like this. So you know there is a formula UT plus what? Have it squared. This is 0 already because your initial velocity is 0. 0 times c is 0. And you are given distance, you can easily get your acceleration easily. Instead of using two formulas. I'm not waiting now. So your distance is what? 60. This is what? U is 0 times 20 plus what? 1/2 times A times time is what? 20, right? 20 squared. I get it now. This is now what now? 60. That's now what? A times what? 20 squared is what? 400 over what? 2. What multiplied? 60 times 2 equals to 400 what? A. Divided by what? 400. 400. That's now what? A equals to what? 120 over 400. What's the answer? That's 0.05. 0.3 meter per second square. Once you know acceleration, you can get your fall because you know your mass. Now, look at this question. A body of mass 8 kilogram. A body of mass what? 8 kilogram was brought to rest. 8 kilogram moving with a speed of 10 meters per second is brought to rest. Once your body is brought to rest, your V will be 0. Final velocity will be 0. My V is 0. And the mass is what? Moving with a speed of what? 30 meters per second, right? It's brought to rest in 2.5 seconds. That's time is what? 2.5 seconds. Magnitude of the force. I told you what the instruction I gave you. Once you see something is brought to rest, I let him now. Look up now. Look up. Look at this question now. I can use this formula to get the magnitude of the force. M A, right? And it's brought to rest. Your V is 0. I can go and get my acceleration. Now V equals what? U plus what? 80. V is the final velocity 0. U is what? 30. A is unknown. Time is what? 2.5. Now what not is now? Bring this collect items. Minus 30 equals to what? 2.5A. Divided by what? 2.5. 2.5. That's A equals to what? minus 12. That's deceleration, because when something is brought to rest, that's deceleration. Deceleration is negative acceleration. Deceleration is what? Negative what? Minus what? 12 meter per second square. Now, F equals what? MA. F is what? We're looking for force. Your mass is what? 8. Acceleration is what? 12. When you are using F equals to MA, you're going to make your acceleration to be negative, unless you want to apply it in equation of motion. Now, what mass is now? That's 96 Newton. That's 96 what? That's 96 Newton. That's 96 Newton. That's 96 Newton, That's 96 Newton. That's 96 Newton. This formula is under equation of motion. You can go and watch my video. I've uploaded on my YouTube page. Equation of motion. Prominent College. Equation of motion. If you are new today, go and watch my class on equation of motion. Equation of motion. I think you know it before. Go and watch my class on YouTube. Equation of motion. Equation of motion. Equation of motion. Equation of motion. He was there. Equation of motion. Go and watch my class on equation of motion this night, and you are going to do assignment from your remix. A man is a win man. You are watching this man, it's just 2 hours video or 1 hour 30, and you are doing assignment this night. Hey, rate of chemical reaction is uploaded also. Go and do assignment on it. No excuse for failure. No excuse for what? Yes, I use all strategy to make sure all my students pass very well. All strategy. I'm attacking in all directions. If you are not there, you are still there, because I've done the video for you. If you are not there, you are still there. I've taught you. If you are not there, I've taught you. Go and watch all the videos. Everything now. Now, that's 96 Newton. That's it. What else if you want to apply this formula? S equals to N V minus U over T. Oh yeah, look up. If you want to apply, let's try it out. N is what? 8. V is what? 0. U is what? 30. Over T is what? 2.5. F. That's minus 30 times 8. Over 2.5. What's the answer? That's 96 Newton. Minus 19 really shows that it's moving in opposite direction. You can also apply that formula and get your answer. Kowi, Rohim, Daniel, at the Basit, wait that boy. You can also apply that formula and get your what? Answer. I'm not communicating now. Hope you are getting it. You will cope. You will cope. I get him now. So there are many ways to catch a fly. If you don't understand this one, due to the equation of motion, I believe you understand this one. It doesn't mean it's just a direction. That man is showing negative, it's showing opposite direction. Man is showing opposite what? Direction. Oh yeah, right. Not the is not allowed. Okay, what was the best? So who is doing this pen? What happened to you? How special are you? What do you do you another student? Okay, I promise you I'll give you data back, right? We have collected it back. So how special are you now? Right. Wow! Look at this question. I don't want to solve this question together. I don't want to solve. I want you to give me ideas on how to solve it. I want to see your understanding. Don't forget, final momentum final what? Momentum formula is what? What final momentum formula? MV, right? What the initial momentum formula? What class? Rashid? Musa? What's the initial momentum formula? MV. Okay, now look at this question now. Yeah, what is the question? 5 meeting. Ask for 5 seconds. Time is 5 seconds. On the mass of 5 kg. Can you see where we are analyzing it now? Initially at rest, U equals to 0. When you are at rest is 0. Going to rest is what? V is 0. Calculate the final momentum. I need for final momentum. That's MV. I need for final momentum. Look up now. What are you going to do? Look up. Do you know that FT and V minus U is the times what? FT Musa Rahim and minus MU. Now this MV is the final momentum. We can bring this minus MU here. I shall go sleep. FT plus what? MU equals what? MV. You can do your mathematics like this. You can turn around your formulas. You can do things on your formulas. I let him now. Now look at it now. So therefore your F is what? 5. Time is 5, right? 5 times 5. M is what? 5. U is what? 0. M is what? 5. Okay, you are for MV, right? Let me leave it like that. MV, which is my final momentum. MV, final momentum. That's this 0, this 0. 5 divided by 25. 25 equals what? MV. 25 what? Kilogram meter per second. 25 kilogram meter per second. That's option what? C. Option C. I have solved all questions. I have given enough example. I've given you enough example. We are going to Newton third law of motion now. Newton third law of motion. Newton third law of motion. Right. That goes since. Where is Abdullah? Where is Abdullah? Where's that? This should be here. Well, do you say no? He or she must try this focus. I get it now. Citizen must deliver on it. That is what former President Jonathan did. Jonathan brings both sides. You know. Jonathan wanted to remove something. Newton third law of motion. Oh yeah, class. What is Newton of motion? Now, as you are sitting on that chair now, there is a reaction on you, and that reaction is what? Upward force. That reaction is what? Upward force. And your weight is the downward force. That's why when you sit down for so long, you'll be tired of sitting, because there is a force acting on you also. So, and the force is equivalent to your weight. The fatter you are, the more the reaction on you also. That's why the fact one cannot stand for so long, because the weight is very high. So for every action, there is equal and opposite reaction. For every action, there is an equal and opposite what? Reaction. If you hit this wall, bam! What goes up with your hand? One of the force you apply is applying a force on you. Is applying a force on you. That's what makes one to scatter, right? And that force that makes one to scatter is what? Reaction. This one of the word, boom! You are going to have any right? That is when you apply a force on you. That force is what? Reaction. Now, for every action, there is equal and opposite what? Reaction. Now, we have observation now. Class it. Hey, 1, 2, ready, go. With equal force. Which one, Now when you are fetching water from the well, the force that is bringing the load upward is called tension. Tension in that rope. Tension in a string is force in a string is called tension. Force in a string is called what? Now the weight of that water is pulling downward, because if you don't hold that rope, what happens to that water? It will fall down, right? So the weight is acting downward. Weight always acts downward. Weight always acts downward. And tension is acting upward to pull the weight, right?
If the rope is suddenly hot, the load falls down. Why you want to the rope? Let's see your hand.
Jump. When you that rope will skip up. Everything now, because the tension is acting upward. This shows that. Okay. Good. Conservation of what? Linear momentum. Conservation of linear momentum. This is about collision now. When two body collides. When two body what? Collides. So now, let's state it. In an isolated system of colliding bodies, total momentum is always constant or easy for more bodies colliding in the ground of isolated systems. Hey, I don't like this class. Principle of conservation of linear momentum state that what?
In an isolated system of colliding bodies, total momentum is always constant.
Which means constant?
Or if two or more bodies collide in a closed or isolated system, the total momentum before impact equals total momentum after impact.
Now look up now. If two or more body collides in the express system, when it's express system, there is no external force acting on them. Maybe there is no third force acting on it. Everything now, when two things are acting on each other alone, I get it now. Express system, the total momentum, that's final momentum, mv. Now this is it. M1 U1 plus what? M2 U2 is equivalent to what? M1 V1 plus what? M2 V2. This is the momentum of the collision. This is the initial momentum. This is the final momentum. The initial momentum is equivalent to final momentum. That's what this one is telling us. That the total momentum before impact, before either is equal to the total momentum afterwards they have what? Collided. Maybe a body is at rest. If the body is at rest and one body is moving towards it to collide against it, therefore the second body that is at rest, the initial velocity will be what? 0. And it is their total momentum. And it's only equivalent to when they collide together, the momentum after collision, when they move with a mass and velocity. Am I getting now? So state the principle of conservation of linear momentum again. In an isolated or closed system, the total momentum before collision is equal to total momentum after collision. Simple as that. It's not hard at all. The total momentum before collision is equal to what? After collision. Now read it again. If two or more bodies collide in a closed or isolated system, the total momentum I can't hear you. If two or more, the total momentum before collision is equal to the total momentum after collision. Now write this note. Write Newton's third law of motion, and I'm going to write principle. External force act. The only two bodies act. No external force act. And neither does itself. The principle of conservation of linear M1 and M2. Moving Moving is what? Respectively. U1 and U2 respectively. And collide, and therefore what? Move up V1 and V2. Then plus M to U2 equals what? M1 V1 plus. This is for what? Principle of conjunction of what? Linear what? Principle of conjunction of linear. Let's read the next part. Hey, need to listen to this now. The above what? The above equation is then what? Before and after collision. Look up. When the body stands in a stationary point, and when the body is not moving, and the body came to collide with the body, we can also use this formula. When the body moves anything now in the same direction before collision and after or collision, when the body are not coming towards each other, when the body comes towards each other, they are moving in opposite direction before collision. When the body moves in the same direction, that's when you are going to use this formula. So I have the formula M1 U1 plus what? Listen first. Now, look up. We are done with this.
Yes.
Now, what if two bodies move in the same direction before collision? We are going to add the momentum together. M1 U1 plus what? M to U2. And both move in opposite direction after collision. Therefore, you are going to introduce negative value here. Introduce what?
Negative value.
So then, look at what the formula.
M1 U1 plus M2 U2 equals to M1 V1 minus M2 V2.
This is when two body move in opposite direction after collision, but move in the same direction before collision. So after collision, that's M1 V1. You put minus there. M2 V2. That's moving in opposite direction after collision. What if two body move in opposite direction before and after collision? Is what? Minus minus. Before collision, after collision. All your class is
M1 U1 minus M2 U2 equals to M1 V1 minus M2 V2.
Easy. M1 U1 minus what? Equals what? Minus what? That's when two bodies move both in opposite direction before and after what? Collision. Who can state the two formulas for me? When the two bodies move in the same direction before collision and after collision, what is the formula? M1 U1 plus M2 U2 equals what? M1 V1 plus M2 V2. When two bodies move in the same direction before and after what? Collision. What of when two bodies move in the same direction before collision and opposite direction after collision? What is the formula, class? Plus what? What is the formula? What is the formula, man? How about you move it back there? What again? When the body moving opposite direction, both before and after collision, what? I wonder if I can. Equals what? M1 V1 minus M2. You must failure. Ignorance, mash it. Give it out here. Jam must submit. You put some like a jam. Minimum. I get it now. I want 330. I want crazy score. I get it now. 360. I get it now. When is 155019? When you see that medal score, that's what she vibrates in different way. Boom! I just want to vibrate and the phone switch off. Crazy score. 352. Too much.